All right, welcome to Unit 2, Lessons 5 through 15 quiz. This is a practice quiz. So this is just for our going through to make sure we're ready for the real quiz. It'll be the same type of questions, just changing the numbers around, things like that. All right, so the first question here is write a third degree polynomial function with the x-intercepts. So when you see these numbers here as the x-intercepts, that means x equals -7. Well, then it follows that x plus 7 is equal to 0. So that would be the first factor. And that's what's happening with each one of these. So I would say f of x or p of x, whatever favorite letter of the alphabet you want. The first one would be x plus 7, and then x minus 8, and then x minus 15. And you could add extra numbers in front and stuff like that, but that's really all you need for that. Convert to standard form. This is where we multiply it out. And what I do is I kind of ignore this one right here, and then I multiply the others two out. And this is where I sing the old clam clause and all that business. So I do x times these two things here, and then green, let's see, green would be this one, times these two things here, and that's what we multiply out. So going back to red, we get x squared plus 5x. Now the green part, so we get plus 4x plus 20. So we're going to simplify this part together. I'm going to go to blue, so we get x squared plus 9x plus 20. And then I'm going to multiply that by the x plus 2. All right, and this all got multiplied by the x plus 2, and then equals. All right, so now we go on to the next part here. Get that back to green. So we're going to do x times these three things, and then we're going to do red times these three things, and that's how we multiply it out. And we sing, oh, clam a clause, oh, clam a clause. So x times the x squared would be x to the third. X times the 9x would be 9x squared. X times the 20 would be 20x. Then we're going to multiply everything by 2. So that's going to be 2x squared, just essentially doubling everything, 18x, and 40. Now simplify it together with the color blue, and we get x cubed, put the x squareds together, plus 11x squared. Put the x's together, be 38 of those, 38x, and then plus 40. All right, and that's the answer to that one. Number 3, we're sketching. I don't know why when I scanned this, I made a line across there. Oh, I bet you I know why. The copier has a dirty speck on it, so when I scanned this, it like got that scan across there. So I think I know how to fix that. Mr. Jackie, the copy fixing guy. Okay, so this right here would be the leading term. So it's negative and odd, so we know that it's up on the left and down on the right. We know that the y-intercept is -6, and then the x-intercepts come from those pieces right there. You said each of the factors equal to 0. So I'm going to make myself a makeshift sketch here. And this first one here means -2, so I go over 2 and put a dot. Then 5 and 3, so I go over 3, 1, 2, 3, put a dot, 5, put a dot. Then the y-intercept is -6, so I'll just go down and -6. So that's -6, this is -2, this is 3, and this is 5. So it has to snake through all of those and be up on the left and down on the right because it's negative and odd. So I'll switch colors to, I guess I'll just do red right here. So here we go. So it's going to come down through, cross here, somehow cross there, and then come up through, and then go back down through and be down like so. So it's up on the left, down on the right, it went through -2, 3, and 5 on the x-axis, and it crosses the y-axis at -6. So that's what that means. It's a basic sketch of it. So you didn't have to do anything except for look at the information and discern what it meant. Okay, going to the next page. Now we got leading term of positive and even. So that would be up on the left. I don't like that. That's a really bad arrow. Okay, it's going to be up on the left and also up on the right. So it's when it's positive and even, it's up and up. Now, there's supposed to be 4 zeros of the function. I only gave you 3, which means there's a bouncing situation. So it has to bounce off of one of those. So we can make it bounce off of any one that you want. You can pick whichever one makes you happy. So -3, 1, 2, 3, put a dot. 4, 1, 2, 3, 4, put a dot. 5, 6, put a dot. So wherever you want to make the bounce happen. I'm going to make the bounce happen right here at 4 because I think I can make it work that way. So it's going to bounce off of 4. I can make it bounce off of any one of them. It doesn't matter. You can make it bounce off the -3, et cetera, et cetera. So here we go. I'm going to go green. So it's going to be up and up. So it's going to be like this. It's going to come through. I don't know where it crosses the y-axis. I'm going to make it bounce off of 4, go down, and then up through like that. And so it crosses here, bounces there, crosses there. And again, you could draw this many different ways. You can make it bounce off of any one of those 3 points. And that's how I chose to do it. But as long as it's up and bounces once, you're good. All right, so now we have to rewrite this as a product of linear factors, and I gave you the first factor. So this means we're going to be dividing. So I have x plus 11, and then I'm going to divide that into x to the third plus 10, x squared minus 23x minus 132. All right, pick it out, multiply it out, subtract it out, drop it out. So the first thing I'm picking out is x squared. That gives me x squared plus 11x squared, or x cubed, my bad, x cubed plus 11x squared. Now I'm going to subtract that out, subtract. That's going to give me -1 left. So it's -1x squared, drop down the -23x. Now I'm going to pick out -1x. I can put a 1 there, that's fine. So it's -1x squared minus 11x. Now I'm going to go to red and add, because I'm going to subtract the subtraction, so that's adding now. And that's going to be -12. So it's going to be -12x and then minus 132. So now I need a -12. So minus 12, that's going to be -12x, and then minus 132, because 12 times 11 is 132. So when I subtract that, it does zero out. So now I know that p of x is equal to x plus 11 times x squared minus 1x minus 12. So there it is, kind of factored. Now p of x is equal to x plus 11. And then I factor it one more time to get to the linear factors. And -4 and +3 is what it'll do it, because if we use the Officer Bell half donut trick, Officer Burnett, we get this and this is -4x, and this is 3x, and that makes the -1x in the middle, and -4 times 3 is the -12. So the answer is right here, linear factors. So if you were to graph this, you would know that the y-intercept is -132. It is x cubed, so it's positive and odd. So it'd be down on this side, up on that side, and then that's where it crosses the x-axis. Okay, number 6 is saying, hey, here's the polynomial right here, and when you put in a number and you get 0, that's basically telling you what a factor is. So this represents a factor. this represents a factor, and this represents a factor. So these ones here are true, but they don't represent factors. So P of 5, negative 5, is 0, means x plus 5 is one of the factors. And then 8 would be x minus 8. Remember that whole thing about it being opposite? And then the 2 one right here would be x plus 2. So that's what P of x is equal to, P of x. So basically what's going on here is when you see this P of negative 5 is equal to 0, that means x equals negative 5 is one of the zeros of the function. It makes it 0. So then you just add the 5 over and you get the x plus 5. There it is as a factor. So there's this connection that we keep talking about between x equals negative 5 and then x plus 5. So here it is as one of the solutions, or the 0 of the function, right? And then here it is as a factor, and those are connected. So there's the answer right there. You just got to know which ones to eliminate. Okay, the next question is multiple choice, and there are 2 choices that work. So the first one that works is 5, 0. So if you put 5 into each of those, you'll get 0 back. And what you're looking for is where the parabola, this is a parabola, and the line intersect each other. And then the other point that works is negative 6, 11. So if you put negative 6 into the h function, if you do h of negative 6, you get negative 6 minus 5, which is negative 11. You also need to put negative 5 into, or negative 6 into the g function. So g of negative 6 is equal to negative 6 plus 7 times negative 6 minus 5. And that would be 1 times negative 11, which is negative 11. So it matches. So those are the 2 answers that make that true. Okay, the last 2 questions are factoring. So we're going to factor, and once we factor, then we're going to set each factor equal to 0. And that's how you find the zeros of the function or the x-intercepts. So negative 9 and negative 1 make negative 9, and then negative 9 and negative 1 also add together to make negative 10. So we do 0 product proper t, x minus 9 is equal to 0, so x is 9. And then x minus 1 is equal to 0, x is 1. So those are the 2 zeros of the function, or the 2 x-intercepts. Now here the factoring is a little bit trickier. Now we have to figure out what multiplies to make negative 12 and then adds to 5. Okay, so if I put 4 over here, the 2 and the 4 multiplied together would make 8. Put 3 here. 8 and 3 differ by 5. The 8 was negative and the 3 is positive. Okay, I think that does it. Let's donut trick it. So here and here, that's 3x. And then here and here is negative 8x. So negative 8 and 3 do make the negative 5 in the middle. Okay, so I'm going to erase my donut work. So get that out of there. So now I'm going to set each factor equal to 0. And 0 product proper t, we get the 2x plus 3 equals 0. X minus 4 is equal to 0. And then we're going to subtract the 3 over. X is equal to negative 3 halves. And then x is equal to 4. All right, so those are the solutions to this. Piece B.